In today's video, I thought we would discuss forge welding a plane iron, or sometimes just called laying an iron or steeling an iron, which all mean pretty much the same thing. But what is a plane iron? Actually, the blade in a woodworking plane, and they're referred to as irons, even though the cutting part has to be steel, because just plain iron won't hold an edge to cut with. So they have to either be an all steel blade, or in the case of what we're going to do today, we're going to weld a high carbon steel onto a mild steel body. Now, this isn't the kind of plane we're making the iron for. This is kind of the generic Stanley style plane that you see all around. This one's in horrible shape, needs to be restored, but I didn't want to bring a nice one to the shop. The blade I'm making, or the iron that I am making, is for a wooden bodied plane, and the irons are held in with a big wooden wedge. And in this case, there's no cap iron. It's just a solid forged blade that is held in with the wedge. So it's a thicker, heavier blade, and the blade will taper a little bit. It's not actually going in this plane. This is just a plane that I happen to have around that someday I hope to fix up. But for now, it looks good on a shelf. But this one will be 8 inches long, 2.5 inches wide, and the customer has asked that it is 5/32 thick at the cutting edge and a 1/16 inch at the back edge. So it's a little thicker than an 1/8, so it's going to taper more than 50% in that 8-inch length. To do that, I'm going to start with a piece of mild steel that is way too long. This is already over the 8 inches. That's about a 9-inch piece of 1/4 by 1 1/4 mild steel. Wrought iron would be a very traditional way to go, but I don't have enough wrought iron, and mild steel is what we agreed upon. But it doesn't need to have that much steel. I'm going to add a piece of 1/4 by 1 1/4 1075, so it's a simple carbon steel with 75 points of carbon, or 0.75%, less than 1% carbon. And this is about 2.5 inches long. And I've already scarfed the end of this, which is just a simple taper, so that it will blend with the mild steel and transition, and hopefully you won't be able to see it, or won't be able to see it too clearly. I really don't mind if you see it a little, because then you'd know that it was really forge welded. That's going to be a fairly large amount of steel on the back of the blade. It will take hundreds of years and several owners to wear out that much steel. The blade will probably get lost and have to be replaced long before the iron is worn out completely. So that's plenty of steel to put on this project. And I will then forge the blade to shape and then cut the mild steel off. This just gives me a handle that I can grab with a pair of tongs that's out of my way while I forge the shape I need for the blade. So we're going to build a coal fire. We're going to do this at a coal fire because it's a fairly small weld, and I think that will be better than working in the gas forge. And while it is certainly possible to put this in the forge and set this on there, there's a chance that when you bring it out to the anvil that it will fall off, and that's a real pain. I've done it. I've seen other people do it. It's certainly possible to be very careful when you bring this out and get it welded without it slipping. But I'm going to take the modern luxury of putting just a teeny tiny little tack weld on the end. That's a part that will be ground off and it'll go away entirely in the end, but that's just there as a helping hand to help hold this in place while I get the forge weld. So I'm going to do that, and then I will meet you at the forge once we have the fire going. Now, making a plane iron is really a fairly straightforward process, and there's not going to be a lot of forge work to show. We're going to do the weld in probably 3, maybe 4 quick heats. We're going to refine the weld in a few heats and start drawing out the blade. Then we'll finish drawing out the blade and take a few low heats to complete the shape of the blade, try and get it as smooth and scale-free as we can before we have to grind it. And that's really about all the forge work that goes into this. So let's make this also more of a review on forge welding and what you can look for when you're forge welding. We'll talk a little bit about fire maintenance in a coal fire, and that's what I've got today. It's not coke, it's not charcoal, it's bituminous coal or soft coal. It's coking coal. So we start with coal in small bits on the outside of the fire, and I tend to keep mine wet because it helps coat it and it helps keep the fire under control. And as it works towards the inside, it coats and starts forming up into softer lumps, and we'll try to take a closer look at this, but we've also taken a look at this in previous videos and we can reference those. But it's the coke that you're actually burning. So when you have a coal fire, you're still burning coke to actually work with. And that's important when welding, because the coal itself has impurities, and you want those impurities all burned off before you start forge welding. Impurities are bad for your weld, and it's bad for steel, which is one reason why charcoal isn't a bad fuel, is because it doesn't have any of the impurities coal has, and it's better for the steel portion in cutting tools. For a plain blade, it's probably not a big deal, and if we're burning just the coke, we shouldn't be picking up impurities. But if you start bringing fresh coal, or green coal as it's called, into the fire, you're going to start having problems, and you're going to have more impurities, more sulfur. You're not going to be able to get as hot. You're going to have to give it more air to bring the fire up. That means your risk of oxidizing and scaling goes up, and then therefore your risk of a failed weld goes up. You need a deep fire to weld in. My fire pot is about 3.5 inches deep, and I've got another 2 or 3 inches of coal or coke above the fire, so I can work in the middle, and all of the oxygen is consumed that way on the way through the fire. If you get down low in the fire, if you take your workpiece, I may have to go shut the door, a little breeze blowing through the front, and that may affect us too. If you take it and stick it down like this, you're down where the air is, and that's an oxidizing fire, and it's going to scale and your weld will probably fail. If you put it in straight and level, the people who designed these fire pots thought of the ideal height, and if we put that in level, that's a nice neutral fire, and that's where we want to heat the material so that all of the oxygen is consumed coming through the fire. For flux today, I'm just using 20 mule team borax, regular laundry borax. I just keep it in a little tin by the fire. It's got a lid to keep the junk out of it, and I'll use a long-handled spoon to put the flux on the weld. So it's just this stuff. It's stuff you use to help your laundry out. It's cheap. This is something like $5 at the grocery store for this box, and it, for me, is several months' supply using it like this. For most people, this is probably a year's supply. So as we go through the process today, we'll probably have the blower on quite a bit. I have an antique Buffalo forge blower on this forge, and it's kind of whiny. It makes a lot of noise. That's why frequently I don't deal with fire issues in the videos, because it's really a loud thing to listen to. So you might need to turn your volume down a little bit, or just put up with the fact this is going to be a little bit of a noisy blower. It has a speed control on it, and I typically leave the speed control all the way up and control it with a damper, and I can shut the air all the way off or open it all the way up with a damper. And that's a pretty good way to work a blower. A lot of the new blowers don't even have speed controls. You just use the damper because it's really a very efficient system. All I want to do initially is let my fire come up to heat, and I want to bring this up to a good high heat and flux it. And then I'm going to put it back in the fire and bring it up to a welding heat. By the way, this piece of sheet metal back here is just to block the breeze, and that helps my side draft chimney vent properly. Otherwise we can have some problems with a little too much smoke in the shop. So that's about the heat I want to flux with. And you can flux in the fire. Some people like to do that. I'm just in the habit of taking it out. Now, why borax? There's lots of different fluxes out there. Now, borax is affordable, but also it's very runny. It really melts and gets down in there, so I don't have to worry about whether I've got flux in that joint. I know the borax is going to get in there. I'm going to put that back in the fire with the high carbon component up. High carbon steel, forge welds at a lower temperature than the mild steel does. So you want it up where the fire is just ever so slightly cooler, and that's enough to make the difference. Now here, I don't know if you can see this very well, but this is coal. It's a hard, shiny, kind of a rock. You can break it if you try, but sometimes it's kind of hard to break. And in here, this stuff that's way too hot to touch, and is coke. And the coke is soft. It breaks up. It's kind of fluffy almost. It's much lighter in weight, and it kind of expands, and it tends to clump up and form bigger pieces. And that's what you actually want to be burning, is the coke, not the coal. Around this outside edge is where I have my damp coal, and I keep it fairly well packed to reflect heat back into the fire, and I work it in very slowly. And as it works in, it's coking in this area right here. Now you can see I brought a little too much in here, and that green smoke means I'm burning fresh coal, and that's not what I want. Now there's none down here in the heart of the fire, so we're okay. You want to bring this up slowly. Too much air is your enemy here. So hopefully that explains the fire a little bit. It helps to have a little window in here so you can kind of see down there. But you want to keep most of this completely covered in fuel so air stays away from it. That way it's not oxidizing, it's not scaling. It heats up better because it's insulated with the coke. But don't be in a hurry to get to welding temp. If you turn that blower up all the way, you're going to just over oxidize it. You're going to start burning it off. It's going to be a problem. And don't stare at the fire the whole time. It'll be bad for your eyes. This is still a fairly fresh fire, so it's not as hot as it will be by the time we're done. But once it's hot, we'll be at welding heat. And I can see one corner of this is getting hot a little faster, so I'm going to move it to a cooler part of the fire and try and position the part that's colder in the hot part of the fire. Now the borax gets kind of runny and slippery in here and can kind of look like you're at welding heat when you're not. So you got to kind of watch the difference between molten flux and that glassy surface just starting to show up on the material. I just saw a few sparks, so I don't really want sparks, so I'm putting that hot part back in the corner of the fire again. We're kind of going for a bright lemon yellow, but you want to pull it out just before the sparks start. You don't want sparks. That's a popular misconception. So that's where we want to be. I've got my hammer ready, and I'm going to start at the end and work back towards myself. I'm only going to do about the last ½ inch, and then I'm going to go back to the fire. That's what I mean by short, quick welding heats. No reason to let it cool down below welding heat. Heats up much better if you don't let it cool down. So it doesn't take long. Once you get that first welding heat, it goes pretty quick. You'll also notice I did not wire, brush, and flux the first time. I'm only going to do that every other welding pass. There's enough flux on there, it just isn't necessary every pass. Before I turn that blower back on, just a couple of things at the anvil. One, my anvil is about a ½ step from my forge. I can pull this piece out just by reaching over to the forge so I don't lose any time going to the anvil. I make sure my hammer is in the same orientation every time. I know the face is away from me, I pick it up like this, I can hammer. If for some reason I want the peen for the next heat, I'll put it away, and that's the way I pick my hammer up. I try to clean the anvil face between welds so I don't have too much scale. So it's a quick process then to come out, pick up the hammer, and get that. This is where the saying, strike while the iron is hot, comes from. I'm going to go back and work the part that I'm comfortable with being already welded just a little bit to start refining that weld. But I'm sure it's not completely welded up here at the scarf, so we're going to flux that one more time. I'm going to go ahead and use a different flux this time though. This doesn't have any borax in it, and it doesn't bubble up as bad. And I think it actually helps get the scarf down a little bit. It's not as slippery, it tends to stay put. I'm just working the area where the scarf is to make sure it blends. Now I should be done needing any flux. If I see anything that looks like it's peeling up, I'll deal with that. But otherwise, I want to get all that flux and nasty scale that it forms with it, or the glassy coating that's flux, off of there. But that weld's looking pretty good. It's going to continue to get refined. Remember, I'm twice as thick here as I need to be. But now I need to spread it widthwise. For that, I'm going to go to this big diagonal peen hammer. It's a old 4-pound hand sledge that I made a diagonal peen out of years ago before I owned a power hammer. Turn one way, it draws metal out. Turn the other way, it spreads. So I know that that's the face I want, and that'll be ready when we come out of the fire. We'll be at welding heat, but we didn't need to flux because we're not actually welding, we're just working a weld. If you only work welded areas at welding heat, they are less likely to shear apart as you work them. I also work with the tool steel up, so it stays hotter, or the high carbon steel. It's not truly a tool steel in this case. But that way it stays hotter. It's stiffer and doesn't want to move as easily. So if it's up, it's hot, it moves better. It also gets more effect from the hammer than what's down against the anvil. I'm still a 1/4 inch thick there, so I'm still thicker than I need to be in the long run. And I'm just over 2 inches, so I'm getting pretty close. Once this is good, we'll start moving up the blade. As this gets close to the size you want it, and you're not doing as much heavy shaping, you can start working it at slightly lower heats. Up here I'm working mild steel only because I'm outside the weld area, so I'm going to turn it over and work it evenly from both sides. I noticed the side closest to me was spreading more, or closest to my hammer hand, so I'm going to work some more on the other side and try and keep that even thick. I'm going to start evening up the edges. I'm going to go to a regular flat-faced hammer now. to get a smoother finish. It's looking pretty good. And no heavy forging at this heat. This is just cleaning up, smoothing. The closer you can get this to exact size, the better off you'll be. Let's mark where I'm going to want to cut it. Now I'm thicker right here, so I'm going to cut it 1 inch long. Should be right there. I just want to mark I can find hot. I can feel my little mark we made. Cut that off. Better if it doesn't cut all the way off like that, but if it does, make sure you find it and know where it's at. Now we're going to spread this out widthwise. Start in the middle and slowly work my way away from my hammer hand. And go back to the middle and work my way towards my hammer hand. This blade needs to taper thick on the cutting edge and thin up this way. So I'm going to continue to work that. Unfortunately, I've lost any evidence of where the forge weld is, which is a good thing. That means it's good forge weld. But it means I got to figure out which side is the cutting side and which side isn't eventually. You don't want to pack a bunch of scale into this. The smoother this is, the less grinding and finishing that it'll require. This low heat, it's just very light smoothing blows. It's a good place to use a flatter to make sure it's as smooth as you can get it. Take another heat and do that again. I do wire brush any scale off that I can before cutting over here. Now I'm just going to take a minute to bring it back up to heat, kind of a dull red. And then we're going to let it cool on the side of the forge. This is a normalizing heat. I frequently will bury something like this in vermiculite because it's softer when it's done and easier to file or grind. But you wouldn't be able to see it till tomorrow, and then the video won't get posted. So we're going to go ahead and normalize, which is perfectly acceptable. It's not a bad technique. Most people, this is what they do. I've just somewhere got in the habit of annealing as a preferential treatment because it softens it even more. That's all I need to do, and I only need to do the part with the tool steel, or the high carbon steel. And I'm just going to set this back here where it's nice and warm, and turn the fire off. Then we're going to go and look for what's called clinker. If you've been paying attention before, you've probably seen clinkers. I'm going to push the good coke and coal away from the fire, because I'm about to put it out. I just want to show you what a clinker looks like. So we're looking down in the fire pot, and I'm going to take a little poker, and I can generally feel the clinkers. There's something hard right there. It wants to lift the whole fire up when I pull on it. That's going to be a clinker. Unfortunately, these tend to break apart. Some coal, they stay together very nicely, some they don't. But this is what a clinker looks like. It's kind of a nasty, glassy substance. It's got scale, it's got impurities from the coal in it, it's got welding flux in it, and it just doesn't do your fire any good. It provides no heat, it consumes no oxygen, so you get a more oxidizing fire if you've got too much clinker. And it just makes for bad forge welds. Now, since I'm not welding anymore, I don't really have to do this. In fact, I'm not even going to use this fire anymore. But if I were welding and I'm going to do another piece, I would do this, then I'd bring the coke back in that I just raked out, push it back in, mount the coal back up around the sides, get the fire back up to heat, and I'd be able to keep working. Instead, I'm going to let the fire go out. I'm going to leave everything that's down in the fire pot at this point in there, and I'm just going to let it go out. This stuff outside is already out. And then I can clean this part out and get the ash and the clinker out tomorrow much easier. This really turns out to be more of a forge welding review than it does to be about a specific project, because I know most people aren't going to be out there making forge welded plane irons. It's not a common thing to do anymore because most people aren't making their own wooden planes, but the person this is going to is making his own wooden plane, and I think he might be looking at making them commercially and maybe needing more plane irons. So this is completely a success. I had real trouble trying to tell which side was the carbon steel side and which side was the mild steel side. I finally had to spark test it to be able to tell the difference, because we did a good enough job that I cannot find any sign of the weld along the edges, the end, or at the scarf. And that's exactly what you want in the long run, although like I say, if you see a little bit of that scarf, it doesn't really bother me because it's just a little sign of a forge weld and a little sign of process, and some people like to see that, and you see that in a lot of the old ones. Here's the blade, rough ground. It's going to need more grinding. It's still just a little thin in here and a little thick out here, so hopefully by the time I have ground this off on this end, which is supposed to be a 1/16 of an inch thick, and it's still almost an 1/8 of an inch thick, I can taper that in and get this to blend smoothly. It's also got a little bow in it that I'm going to have to straighten out. And it's still 3/16 of an inch thick through here. So I got material here and here I can take down. I hope that gets rid of this thin spot. Why is that thin spot there? That's right where my scarf is, and because I made sure the scarf was welded down, I thinned that a little bit much. So if I need to redo this, if I can't get that out, I will either start with whiter material or maybe a little thicker material to give me more to work with. I really thought I had enough, but it's just barely enough, and we might be good and we might not be. It's going to be close. But I'll continue to work on this. Then I'll heat it up, put my touch mark in the side that'll be up when the plane is in use. These are usually used bevel down, so that means the touch mark would be back here. But that's pretty much it. It just needs some more grinding. The backside needs to be smooth, the side opposite the bevel, because you need a smooth surface on there and the bevel to be sharp. But this up in here does not have to be perfect, so I'm going to leave this more or less as forged on the surface unless I have to take out any high spots. And for the most part it looks good. I think we might be a success. We'll find out later. As I say, that's more of a forge welding review. Clean, deep fire, an neutralizing fire, not an oxidizing fire. If you've got too much air, too high a velocity of air from a blower that's moving way too fast, you're going to end up burning things up and not really getting a good welding heat. You're going to create scale, and scale interferes with the weld. So a deep fire is necessary. If you've got a makeshift forge, you may not be able to forge weld. You may have to wait and learn forge welding skills when you can manage to acquire a better forge with a deep fire pot. I'm not going to get around to heat treating it today because I've still got a fair amount of grinding to do. Finishing is a big part of things like this. So, hope that was enjoyable, hope it was educational, hope you enjoyed it in one form or another. Give it a thumbs up if you can. Love it if you hit the subscribe button. Stick around, watch a few more of the videos. Share the videos with your friends, but then make time in your day. You know it. Get out to the shop, make something, have fun, but do stay safe, and remember to wear your safety glasses. We'll see you for the next one.